All right. There is some echo. No? Hey everyone, my name is Martin Hochel. I work as a principal engineer at Productboard in Prague, Czech Republic. I'm GD for web, Microsoft MVP as well. You can follow me on Twitter. He's following me on Twitter. Is it good? Cool. So, you can follow me on Twitter. Just a second. I need to start the timer. Nice. My handle is Martin_Hotel. I publish technical articles at medium.com and I do some open source. Last but not least, I'm organizing the biggest JavaScript meetup in Prague. It's called ngParty. Yes, that ng stands for Next Generation JavaScript. That's right, yes. And I also started React Girls in Prague. And if you're into podcasts, I'm doing a podcast. It's called Tech Taboo, so tune it up if you're into podcasts. All right. So I need to make a disclaimer before I start this talk. I might be biased because of two things. I love TypeScript, and I love Idiomatic Javascript. So should I proceed? 3 people only? That's not very convincing. Okay, I will proceed. Thanks. So, to describe the structure of this talk, we'll be using one environment, which is written in TypeScript, and this talk is about TypeScript. So the whole talk is going to be executed from VS Code. With that said, yes, there might be some live coding, so bear with me. With that said, are you ready to do this? Are you ready? Nice, I'm not, but it's going to be fun. All right, so this is my editor, Markdown, very programmatic environment, right? So we will cover 6 points. Hopefully we will make it to the end. So first thing, CLI. So how do you initialize a TypeScript project? Well, you can use --init. So let's try it out. And I prepared some Webpack aliases, but that's not important. What is important is this tsc-init. And if I run it, a tsconfig has been created with some defaults, right? But most of the time, those defaults are not sufficient. And because of that, you need some flags. And thankfully enough, TSC binary allows us to use these flags. So I can copy all of this code and go back to the terminal and execute the same. But instead, just in it, I will provide all these flags. And I will execute it. And there will be a new tsconfig created. Actually, it will not because it already was created, so I need to remove it first. Cool. And let's execute the command once again. Nice. And now, if you take a look, there is a tsconfig with our predefined flags. So we have target, we have module, we have their source maps, JS6 preserve, etc., etc. So this is just a small pro tip how to bootstrap new project in TypeScript. What else? Well, maybe sometimes you need to resolve some configuration, right? Like, hey, dude, this project doesn't work because it doesn't compile something, etc., etc. So for that, there is this show config flag, which will help you with all your issues. So if I execute tsc, the show config, it will show me my configuration, right? And what's even better, it will spread the files that are included into the compilation process. So this is very helpful for any kind of debugging. And last but not least, if you're having some, let's say, performance issues with TypeScript, or you just want to measure how long the compilation takes time, there's this flag called extend Diagnostics. So if you execute it, you will get this very helpful report from the compiler, right? So like check time, bind time, etc., etc. So that's basically it about TSC binary. What's next? So second chapter, language features. Pro tip number 1, class accessors. So probably you are used to work with classes. Who is using classes in the room? 40%. Okay. And you might see or written code like this, right? So using public accessors in your classes. May I remind you, this is not C# or Java. and you don't have to use them explicitly. Because by default, every method and property in a TypeScript class is public. So you can just omit them. That's just a tip number one, and it relates to the idiomatic JavaScript that I really like to write. Because when you're introducing TypeScript to newbies, it's much easier to understand, right? There are not that many differences between vanilla JavaScript. On the other hand, what about private accessor? I guess you definitely use private in your TypeScript classes, which is okay, right? Here we have some service, we have some private greeting, some private format. Looks good, until it isn't. Well, if you are shipping this as a public API of your application, it can be hijacked. Because here, I'm setting some value to greeting, which was marked as private. But it's marked only in TypeScript. In a runtime, it's still there. So if you're using compilers like Stencil, it will really make it private, that's fine. But if you're shipping raw APIs, try to avoid private. So that's thing number one. Also, when you start using private, you are switching from structural type checking to nominal type checking. What does it mean? Let's say we have here some component, and it uses some kind of dependency injection with our greeter service, and our greeter service uses private, right? So far, so good. Let's say you want to write a test for this component. So we will create a mock. Like we can see here, a greeter service mock, right? It implements all those APIs, and then you want to manually instantiate that component, and you will get type error. Well, of course, because we are not in the structural type system anymore, we are using a nominal type system. So this is kind of ugly, because how to mitigate this, you need to cast it to unknown, and then to the greeter service. So just, stay away from private. It's not private, really. If you really need to ship private APIs, use some other constructs, or just wait for the private instance fields in classes. All right. Next thing, namespaces. So in the ancient TypeScript shipped namespaces. Ancient time equals ECMAScript 5, right? We didn't have any native modules, so TypeScript came with this namespace thingy, again from C#, I guess. But nowadays, please don't use it. It isn't part of a language, so just use exports and imports, and if you really need to namespace something, you can use import star as your foo, right? And this is gonna be, your foo is gonna be your namespace. So again, you're using idiomatic JavaScript while leveraging TypeScript. So please don't use namespaces. Tip number 3, enums. Who is using enums in the room? Oh, okay. You're gonna hate me about this one. So I highly encourage to don't use enums. Why? Let me show you. So here we are defining some enum response with no and yes. Under the hood, this is no is literal 1, and yes is number 2. And if we check some type safety measures with this type, we will see there are flaws in typing system, right? So here we have a test, which is the type of response no, and basically I can assign any number to this. This is not very good, right? I need to be explicit, and I need to use the references of that enums to make it type safe. This is quite unhandy. Again, if you're shipping public APIs, this is very bad API, because you need to ship that enum reference and your functions. Also, if you want to use it inside some kind of function, so here is a function response, and the second argument is using the response enum, and here is again the same type flaw. I can use anything, no type errors, but this will be a runtime error for sure. So instead, we should strive to use idiomatic JavaScript. And how do we define enums in idiomatic JavaScript? Well, with object dictionaries. Again, in not so ancient times in TypeScript, this wasn't easily possible. So in those times, enums were okay. But now we have these sconst, which are called const assertions, and they will not narrow or type. So with that, we have strict type over objects, which keeps values and keys as we define those, right? So we don't need to use enums. And if we use this response, we need to also create a type, because enums, original enums are doing two things. They are providing you type information and runtime information. So again, to achieve similar with object dictionaries, you need to create a type, and this response will merge with this runtime token. And here we are doing some map types magics. We are just extracting the values from this response, so 1 or 2. So in our case, response is going to be a union of 1 or 2. And if we apply those same tests with idiomatic JavaScript, we will get proper errors, right? I cannot assign 4, I can only assign 1 or 2. And the same applies for the same function called respond. So no enums. I warned you. Interface versus type. Most of the questions I'm getting is folks are asking me, hey man, you know TypeScript, right? Mm-hmm. So what is the difference between interface and types? Is it the same? What is this madness? So it's quite easy. There are only two differences. Interfaces are open, types are closed. What does it mean? I'll show you. Open means you can define multiple interfaces with the same token name, and they will merge into one final declaration. This is very vital for public APIs. If you're shipping libraries with some public interfaces, use interfaces, because anybody else can extend this. Like, let's say, you've missed some flag in the arguments, anybody can really easily fix that in his project. So they will merge, and here we have a kitten of the merge type kitten, and yes, it defines color and purse property. With types, you cannot do that. You can define only one unique type alias per scope, right? So there's the difference number 1, and of course, difference number 2, you cannot use unions with interfaces. So let's say here we have a type point, here is a type shape, type perimeter, and now we are creating another type, which is a shape or perimeter and point. So you cannot use this type to extend some interface or implement some class. So easy, just two differences. All right, empty object. So probably you saw signature like this, right? This is standard JavaScript. You are initializing some value, some reference to an empty object. Well, I'm sorry to say, but this is not an empty object, like, because there is a prototype, right, and all these constraints of JavaScript. But this is quite valid. What is TypeScript doing? Well, it infers these quotes empty objects to this empty square literal. And this is a very dangerous type. Please don't use it. Why? Let's take a look at some tests. As you can see, I can basically assign anything to this object. Strings, functions, numbers. Well, I cannot assign null and undefined, but that's very dangerous type. It's a former bottom type. Now we have unknown. So if you really don't know what type you should use, you should go for unknown. So please skip this type. It's very dangerous. So instead, you can use this object type, right? This is better option, how to initialize like empty-ish objects, but still, you can assign like functions and arrays because those are objects in JavaScript. So that makes sense. What's the better option? You can define a records type with this empty object, and now we will have all errors, right? You cannot assign strings like non-objects. It has, again, one design flaw because you can set any kind of property on this object. So if you want to be really restrictive, you should cast or assert this object to some particular shape. In our case, the empty object is going to be empty, but you will be able to assign or set only who property. So in this last case, we have all errors, which is correct. So only this is valid, right? Because we are assigning the same shape, and here we are setting the known who property on the object. So just don't use the empty object literal. Never, ever. All right. Those are language features. Let's cover some API tips. So, when you are writing applications or APIs, whatever, in TypeScript, how do you approach some data models or some shapes, right? So this is like the standard procedure. You will create some interface, right? Then you will create a factory, and this factory will be explicitly typed that it returns this interface. This is okay, but we can be much smarter and much more efficient. Because in this case, let's say backend will change this API to be completed, right? So now this was changed, and now we need to refactor things on 2 points, in the interface and in the implementation. And this is not very like efficient, and yeah, it's kind of error prone. So instead, we should strive to use runtime implementation as a source of truth for types. What I mean by that? So here I have my to-do factory, right? There are no types. It's returning something. The TypeScript can infer what it is returning. And instead, we can create a type alias, which via map types will infer this value, and it will create this model for us to do, right? So when I will change something, I will change only the implementation detail, and the type information will be inferred automatically. So this is a very good pattern to use. And last but not least, it's good approach to merge like tokens. In our case, we have two to-do, right? What is this doing? TypeScript is merging to-do to 2 things: implementation, the factory, and the type. Then, when I want to use it within my application, I'm importing only to-do model, but I'm using it here as a runtime, right? This is creating a new instance of to-do, and in this case, I'm using to-do to annotate some arguments. So very, very flexible APIs, easily doable. So there you have it. Tip number 2 regarding APIs. Again, here we have some module, like user module interface, and we have some functions, and they are exported, right? And then you have a barrel file, which re-exports the whole API. So if you are author of the library, you are saying, all these APIs are public, so I'm just re-exporting those. This is okay. But sometimes you might get picky, and you might import just some of these interfaces or functions to your consumers. And if you do that, you will get an error, right? Like user model. Well, again, TypeScript is helping us here, because if you're using Babel, Babel will strip the inert types, and you will be shipping to your consumers some export with user model, but user model doesn't exist. So if somebody would import that, he will get the runtime errors. So this is very dangerous. So how to mitigate this? Well, if you want to pick some particular APIs, just export the runtime information, and you can use type alias with dynamic imports. This is this import, and I will import user module from API module, and I will basically just redeclare that value and export it. Now, when Babel will process this file, this will be removed, so this is correct module. All right. React tips. Do we have any React developers in the room? Ooh, 60%. Cool. So you are at the right place. All right. How do we define React component in TypeScript? We define props, right? And then we have here section component, which uses this react.fc, which stands for functional component, and is a generic, and we are using that type literal props. And so magically, those types are inferred to the props argument, so I can use this, right? But there was this word magic. I don't like magic. People don't like magic, I hope, especially in programming. So to keep it really idiomatic, what I encourage you to do is to just keep React functions and just annotate props explicitly via props. With that, we have an errors, right? Props.children is not defined. Well, that's good, because I didn't define it. I don't want to provide some magical APIs for my consumers. So we need to be explicit. So let's explicitly define children on our props. And usually in the community, you can see something like React Node, right? And now everything is okay-ish. But let me demonstrate the issue with those children. I can set it to the empty object. It can be null. Well, this is definitely not the API that I wanted to provide to my consumers. So what's the problem? The problem is with React Node. Why is that? So if you take a look at the implementation, it's a huge union on various types. And here are the main issues, like null or undefined. And it's a union of React fragment, which is using that empty object button type. So this applies to all these type flaws that I showcased previously. So you should avoid React Node at all costs. Instead, I definitely recommend to use React Child. So let's use React Child. It's there. Awesome. So now if I want to do some nasty things, like empty objects or nulls, we are all covered, right? And let's say I want to use like multiple children. Now I will get a type error because I allowed only one child. So again, it's up to you. You need to be explicit to explicitly define that that your children should be React Child or array of React Child. And now this is all good. All right, last thing. What about default props? So let me define some default props in React. And let's make our title default. So I'm gonna be saying like title, it's gonna be by default hello. All right. Now TypeScript is smart enough, and if I will remove the title, there will be no compilation errors because title is optional, right? Yep. So again, this is okay-ish, but somebody will change the default props to titles, right? No errors, everything works. Oops! Again, this is not very good API. So what should we do instead? Well, again, we should strive to use runtime information as a primary source of truth. What I mean by that, I will just cut this, and I will create old good constant called default props, just like that. Now what I need to do, because I'm gonna use runtime values for type system, I'm gonna remove this title from the props, and instead I'm gonna use intersection, and I'm gonna infer the type of default props, and I need to mark it as partial, because those are gonna be optional in the interface, in the final interface. And last but not least, I don't have to even use those specific React APIs for defining defaults, because we already know how to define default values in a function. It's a very well-known pattern. So what you can do is just merging our default props with the props that are incoming to the component and just destructure those values. All right, here, and then I can use it within my component, and everything works, and title is still optional, right? So explicit APIs, no magic, easy. All right, that was React. What about vanilla JavaScript? Let's be honest, who dislikes TypeScript in the room? Ah, some hands. I can't see properly, but it was like 10 people. Good, you are again at the right talk. I will show you. So, let's say we have this Webpack configuration. Who is using Webpack? Most of the folks, yeah. So, yeah, it looks okay-ish, right? So let's bundle our app. Oops, there are some errors, of course. So you have two options how to fix it. Option number one, you can pay some advanced workshop about Webpack and become senior Webpack engineer, or you can use TypeScript to help you out for free. How can you do that? We just need to enable type checking in JavaScript via this ts.checkpragma, and I have immediately like squigglies and errors in my file Oh, of course, I forgot to import path from Node. Okay, that's fixed. Export, what's that? Property export does not exist. Did you mean exports? Ah, yeah, typo, of course. All right, and there are also some squigglies, like env implicitly has any type, and I can do some quick fixes, and it will infer some JS doc for me. No errors. Right, let's try it. Well, still doesn't work. You know what? We are better than that. We can use some standard things like JSDoc to annotate or configuration. So let's do that. I'm gonna use type. And because some wonderful folks at open source, they already implemented ambient definitions for Webpack, so I can leverage those. So I will just use dynamic import of a Webpack library, and I will use configuration type from that. Okay. And here is our error. It's not fill name, but it's file name. Ta-da! And of course, Webpack doesn't support any Game of Thrones properties, so your watch has ended. Let's remove this. This looks solid, no errors. Finger crossed. Let's bundle our app. Done. Right? So you don't have to write TypeScript if you don't want to, but it can still help you even in this kind of things like configuration, your bundlers, etc., etc. All right. What's next? This is quite new. So you are a developer that writes things only in vanilla JavaScript, right? And you ship this good library, and you are getting rants from these TypeScript folks at GitHub issues. Hey, dude, why are you not providing types? What is this? It's 2019. We need those types. And you're like, oh no, what should I do? Should I now learn TypeScript or what? Well, TypeScript to the rescue. Since TypeScript 3.7, TypeScript understands JavaScript, and it can generate typings from your vanilla code. So before we move on, let's explore this library. We have here some greeter, which is a factory. I'm using, again, JSDoc to annotate the greeter like function argument. Then we have some greet, again, annotated by string. So that's nice. What about these utils? There is no type information at all in this module. Okay, whatever. So what we need to do, we need to create a tsconfig, and we need to turn on emit declaration only to true. And also I'm providing some declaration directory to typings. So I'm telling the program where it should output those types. So let's try this. I'm gonna execute some command, which is just executing TSC binary on this particular library. Let's do this. Done. And what was done, if we take a look in our folder structure, there are typings for my vanilla JavaScript library, and the greeter is properly typed by strings, and even utils is properly typed thanks to powerful TypeScript inference. So I know that enable is optional, and type of boolean, and all those other methods have been inferred. So this is quite excellent, because now all these people that have been ranting on your GitHub issues, they can immediately start using your library in their TypeScript code, which is typed. So this is truly awesome. Last thing, TypeScript JS and Node.js. So who is writing like backends in Node.js in the room? Okay, 30%. So we at work, we are writing a lot of scripts and help libraries in Node as well, but we want to write it in TypeScript. So until now, we use TS Node, which basically like compiles down the TypeScript and executes it, but it feels very dirty to me. So there is a much better way that we started using this year, and I will show you. So the most important thing is to create a module TS, which is a source of truth of public API of your scripts or libraries. And if you take a look at To-Do Manager, right, this is some complex module that is using TypeScript. Also, there are utils that are using TypeScript. And this module is going to be used in index.js. You might be thinking, like, this dude is drunk. Like, what is he doing? Let me show you. We can use Babel for that, right? So here I'm defining some default Babel configuration, and we will use Babel preset env for whatever reasons, but the important thing is preset TypeScript, and this will strip our types. And to be able to do this without compilation step like dynamically, we can use Babel register, and we are using our configuration, and you need to explicitly provide the extensions. In our case, we want to support TS and TS6, right? And all that is happening here, I'm just re-exporting my TypeScript public APIs via CommonJS and vanilla JavaScript into the node. So now, if I run node, I'm out of time, but just give me 2 more minutes. I will create cons library, and I will require my node library, which is written in TypeScript without compilation step. So src, right? So this is the import path to that index.js, and I'll press it, and there are no errors. And if I just use this library, there it is. There is this TypeScript API, right? So this is quite powerful. Definitely don't use it for production, but for scripts and local like packages, if you're using monorepos, this is an excellent choice. All right. And we are at the end. Back to the slides. So there is even more stuff. And if you're interested to learn more, I've written this article about TypeScript pro tips and patterns. So definitely check it out. I've even written more articles, of course, because I want to share the knowledge with all of you folks. So make sure to check those if you're interested. Give me some comments if you like those or if you don't like those. I appreciate those comments as well. And before I wrap up, stay type safe all the time. It will help you have a good sleep and a happy life. And with that said, thanks for having me. Follow me on Twitter and enjoy the rest of the conference. Thank you.